Chapter 9, Number 19. To make a bounce pass, a player throws a 0.60 kilogram basketball towards the floor. The ball hits the floor with a speed of 5.4 meters per second and an angle of 65 to the vertical. If the ball rebounds with the same speed and angle, what was the impulse delivered to it by the floor? So we begin with remembering that the impulse, which of course is just F delta t, is also delta p by the impulse momentum theorem. So I want to find out delta p. And delta p, of course, is p final minus p initial. So I really just need to find these two things. For pi, we have the triangle shown, and that will have an x part that is mv0 sine theta, and that's in the x hat direction, because it's moving in the plus x. And then we would have mv0 cosine theta, but that points in the minus y hat direction, because it's heading downward. Likewise for P2, we have PF, and that will be mv0 sine theta in the x hat, because it's heading to the right, and then mv0 cos theta, but this time in the plus y hat, because it's heading up. And finally, we just want to find their vector difference. So delta p, which is pf minus pi, which is mv0 sine theta x hat, and then minus mv0 cos theta y hat. And what we see is we have over here, this term and this term are the same. So something minus itself is 0. But this term minus itself, we end up with twice mv0 cos theta in the y hat. And we throw in our numbers, 0.60 kilogram times 5.4 meters per second times cosine of 65 degrees in the y hat, and we end up with 2.74. Really 2.7. And then our units are just the kind of crazy kilogram meters per second in the y hat. So the impulse is that much, is 2.7 kilogram meters per second upward. You could also, this was a little formal, you could think of it a little bit less formally by realizing that the x components are not going to change, so the only change is in the y, and so it goes from being something downward to being the same thing upward. So it's twice that thing. And it's a different way of looking at it.